Okay, I'm going to start talking about 2.6 in the AP Calculus textbook. It's about the derivative of inverse functions. If f and g are inverse functions, then we have this rule. G prime of x is equal to 1 over f prime of g of x. Inverse functions, to find an inverse function, you do two things. You switch x and y, and if you need to find the inverse function, you solve for y. So they give us an example in example 1 here. They give us f of x equals 1/4 x cubed plus x minus 1. They want us to find f inverse of x when x is 3. So first thing I might do is put a 3 in. So let me put a 3 in, and let's see what we get. If I put a 3 in, 3 to the third is 27, so this would be 27 over 4. This combines to give me 2, which is what? 8 over 4. So does that mean f of 3 is 35 over 4? Or does it give me an ordered pair for f of 3, 35 fourths? Okay, I'm looking at this, and I think I might be going the wrong way. If I put in a 3, that gives me f of 3. Is that correct? Does it ask for f of 3, or does it ask for f inverse of 3? We want f inverse of 3. So if you don't mind, I'm going to re-examine this thing. And instead of putting the x as a 3, we're going to make the y a 3. So if I make this y a 3, let's see what we get for x. Because if it's an inverse, you're switching x and y. So instead of x being 3, y is going to be 3. So what do I do here to solve this? Let's see. If I subtract 3, I'd have 1/4 x cubed plus x, and would that be minus 4? Let's see. I could actually just solve it, or if you put a 2 in, 2 to the third is 8. 8 divided by 4 is 2. Put a 2 in here, and that gives you a 0 equals 0. So I do know that one of the solutions is 2. Now I'm wondering if I could actually solve this another way. If I multiply everything by 4 to get rid of the fractions, I would have this. And again, if you put in a 2, it would work. So do you agree that f of 2 would equal 3? In other words, the f function has an ordered pair 2, 3, right? So the g function is its inverse, which you switch x and y. So it would be 3, 2. So f inverse of 3 is going to equal 2. I'm sorry I took the wrong approach initially. But you don't want to make x equal 3. Because it's an inverse, you want to make y equal 3. Now, we learned for part B, I believe, a rule. I think it was it's this rule right here, actually. 1 over f prime of g of x. So that's going to be 1 over f prime of what? The inverse. The g is the inverse. So g is the inverse, and we want it at 3. So would that be f prime of 2, I believe? So what would that be? What is f prime of 2? Well, first we need to find f prime of x. 3 times 1/4 is 3/4 x squared. The derivative is 1 and 0. And if you put in a 2, 2 squared is 4, so that gives you 3 plus 1, I think would equal 4. So hopefully this answer is 1/4. Let me check. Okay, we're also going to talk about the derivative of inverse functions, namely inverse trig functions. Here are your 6 inverse trigs, and the derivatives are as follows. For arc sine of u, it's u prime over the square root of 1 minus u squared. Arc cosine is the exact same thing, but with a negative. Negative u prime over radical 1 minus u squared. Arctangent is u prime over 1 plus u squared. Notice there's no radical. Whereas arccotangent has negative u prime over 1 plus u squared. Again, the only difference between these two is a negative. So the derivative of arcsecant of u is u prime over u square root of u squared minus 1. Now they really should have an absolute value here, which they do. Now the arcsecant of u, its derivative again is negative. I'm sorry, that should be arccosecant of u. Arccosecant of u should be negative u prime over absolute value of u times u squared minus 1. With practice, you're going to notice, you'll get these down. But please notice the only difference between the arcsine derivative and arccosine is a negative. The only difference between arctangent and arccotangent's derivative is a negative. The only difference between arcsecant and arccosecant's derivative is a negative. You've heard me say it before, I'll say it again, the derivative of all cofunctions are negative. Derivative of cosine, cotangent, cosecant, and arccosine, cotangent, and cosecant are all negatives. Anyway, you're going to need to learn these formulas. For right now, write them on a note card. Hopefully they'll make it up to the brain, because we do need to learn these formulas. I think the front cover of your textbook has all about 22, 23 derivative and integral formulas that we need. Okay, here's example 5 in section 2.6. We're going to find the derivative. I left space over here because I noticed this was a product and needs a product rule. But I think we might now know the derivative of y is dy dx. The derivative of arcsine of u is u prime over radical 1 minus u squared. So u prime over radical 1 minus u squared. So let's do it again. If this is arcsine of u, this is u prime over radical 1 minus u squared. In other words, all I did was follow the formula that was given here. U prime over radical 1 minus u squared. Any questions on the derivative of arcsine of x? X prime would be 1, right? Or dx dx. Over here we have a product, so I need to do a product rule. Bring the x down, power times the base to the 1 less power times the derivative of the base, plus bring the radical down times what's the derivative of x? Just 1, right? So let's see what we have here. We have 1 over radical 1 minus x squared. This would be minus the 2 and the 1 half. It's minus because of that. X times x is x squared, I think. And this would be over the radical 1 minus x squared. And this would be just a radical 1 minus x squared. Okay, at this point I'd like to get a common denominator. It appears 2 of them already have a denominator of radical 1 minus x squared. That would be the 1 minus the x squared. How do I make this other one have this denominator? Well, you multiply by the common denominator divided by itself. That makes this. So what do we have here? We have 1 plus 1 is 2. So this gives me 2 minus 2x squared. If you factor a 2 out, would that be 1 minus x squared? On the bottom, you have 1 minus x squared to the 1/2, because it is a square root. What do you do with exponents when you divide? You subtract. So what do you have? What is 1 minus 1/2? 1/2. So the answer should be dy dx equals something like this. Okay, I think we're going to make the assignment 2.6, 19 to 43 odds. For 19 and 21, they want us to find dy dx at a specific point. That usually involves just finding dy dx. Many times it's implicit. The derivative of x with respect to x is dx dx, or 1. The derivative of y to the third power base, 1 less power derivative of the base, is 3y squared dy dx. Minus 7 times 2 is 14, y to the 1 less power times the derivative of the base. Since it's a y, I put a dy dx. And the derivative of a constant would be 0. I'm going to factor out a dy dx out of these two on the right. And solve for dy dx by dividing, because the opposite of multiplying would be to divide. So what do I have here? I have 1 over 3y squared minus 14y. The only question is, what's y? Apparently it's 1. So you get 1 over 3 minus 14, I believe, which is 1 over negative 11. Okay, after we got 21 here, this is a product, so I'm going to have to do a product rule. U times V is going to be U V prime plus V U prime. So let's see, U is x. The derivative of arctangent is U prime over 1 plus U squared. Then I bring down the arctangent times the derivative of u. The derivative of x is just dx dx, or 1. So I get x plus 1 plus x squared plus arctangent of x. Now on the right, I have to take the derivative of e to the y. The derivative of e to a power is e to the same power times the derivative of the power equals e to the same power times the derivative of the power. So basically you have x over 1 plus x squared plus arctangent of x, all divided by e to the y. Again, I won't accept a fraction in a fraction, but remember, we're just finding a value. So if you don't mind, I'm just going to plug some things into here. Arctangent, and it's all over e to a power. What do I put in place of x? In place of x, I'm going to put 1s. So there's a 1 and a 1. And a 1 over here, I think. What is the y? Natural log of pi to 4. So what do I have here now? I think that gives me 1/2 plus the angle whose tangent is 1 is pi over 4. And it's all divided by, e and natural log eliminate each other, just pi over 4. So you have 1/2 plus pi over 4. It's divided by this. So that means you're multiplying by what? 4 over pi, the reciprocal. So when you multiply here, you get, I believe, 2 over pi. I don't know if they want a common denominator, what they want. That'd give me 2 over pi plus 1. If you distribute here, you get a 1. 1 could be called pi over pi. So I don't know. What do they have for their answer? Let's take a look and see if we can match their answer. Okay, let's move on here. Next one, 23. I have a formula for the derivative of arc sine of u. The derivative of arc sine of u. We've determined here that u is x plus 1. So its derivative, u prime, would just simply be 1. The derivative of arc sine of u is u prime over radical 1 minus u squared. So all I really have to do is fill in what is u prime. U prime is 1. What is u that I fill in? X plus 1. So basically this is their answer. I believe they simplify it, but you would have 1 minus, and that would be x squared plus 2x plus 1. 1 minus 1 on the bottom makes 0. So you'd have negative x squared minus 2x, I believe, under the radical. So I believe this is the answer that they're going to have. Let me check. Okay, the derivative of arc cosine is almost the same as the derivative of arc sine, except it has a negative. So it's almost the same formula. So when I take the derivative here, I'm going to keep the 3 out as a constant factor. And I'm going to do u prime. What does it appear that u is? Is u 1/2 x. So what's u prime? 1/2. So I would have a negative, because negative is part of the formula. I would have u prime, which is 1/2, over radical 1 minus u squared. And u is x over 2. So at this point, I think I have a negative 3/2 on top, a radical 1 minus x squared over 4. This seems to cause problems a lot of times, but I won't take a fraction and a fraction. What's the opposite of dividing by 2? Multiplying by 2, but look how I'm doing it on the bottom. Is the square root of 4 still 2? Am I still multiplying by a fancy form of 1? Anyway, what do I get on the top now? The 2's would cancel, leaving me a negative 3. Inside, I think that would give me the radical 4 minus the 4's would cancel. So hopefully f prime of x is going to equal negative 3 over the square root of 4 minus x squared. Okay, arctangent of e to the x. Again, this is just following a formula. Are you aware that arctangent and any of these trigs sometimes are written like this, with tangent with a little negative 1? Anyway, the derivative of arctangent of u does not have a radical. It's u prime over 1 plus u squared. Can anybody tell me what u appears to be in this question? U is e to the x, right? What's u prime? The derivative of e to a power is e to the same power times the derivative of the power. So is u prime also equal to e to the x? So if I was to do u prime over 1 plus u squared, yes, you need to know that a power to a power, you multiply exponents. So here's your answer for this one. You'll find these aren't too bad if you don't mind following the formula, because that's exactly what you're doing, is you're just following a very straightforward formula. Again, I think the formulas are summarized on page 185 in the textbook. Okay, in the interest of time, I may come back for 31, which is again another product rule, but I'd like to look at 41. It's a tangent of the arc sine. Okay, do we know the derivative of tangent of u? Derivative of tangent is secant squared of the same angle times the derivative of the angle. So what this means is it is secant squared of what's u? What does it appear that u is here? U appears to me to be arc sine of t, right? So the u here, I'm going to put arc sine of t. Now times u prime. If u is arc sine of t, what's u prime? Well, u prime over radical 1 minus u squared, so it'd be something like this. 1 over radical 1 minus t squared. Okay, so now I need to find the secant squared of the arc sine. So, I probably still need a triangle, so if you don't mind, I'll make a little triangle here. I'll mark my right angle and my angle. Sine is opposite over hypotenuse, opposite over hypotenuse. The sine of this angle is t over 1, right? That makes this missing side this. So I need the secant squared of this angle, which is 1 over cosine squared of this angle. So that's 1 over, what is cosine? It's going to be cosine squared. But what is cosine? Cosine is adjacent over hypotenuse. So I think that would just be this. So what happens here? I think you get 1 over, squaring the square root gives you this, and the square root. So I think it could also be written as 1 over 1 minus t squared to the 1 1/2. I did that out the longer way. I want to see if we can do this another way if you do not mind. I think this might be the preferred approach. G of t equaled the tangent of the arc sine of t. Do you agree that this triangle, let me draw it again, with this triangle, I need the angle whose sine is t. Opposite over hypotenuse is the sine of this angle t. Find your missing angle. I want tangent. What is tangent? TOA. Opposite over adjacent. Now, if I was to do the quotient rule on this, do you think it might end up with the same answer? It should, right? So maybe let's try this. Quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom. And that's this. All over the bottom squared. So what do I have? I have radical 1 minus t squared. Minus and a minus makes it a plus. The 2 and the 1/2 cancel. T times t is t squared. And the negative 1/2 means the radical is on the bottom. So this is 1 minus t squared because you squared the square root. Now what happens if you do this? Well, on the bottom you'd have what I have on the left. you'd have 1 minus t squared to the 1 1/2 or 3/2. That's the same thing I have here, right? On top, what would you get? What would that give me? 1 minus t squared plus t squared. So what do I end up with on top? Just a 1. So notice we get the same answer, whether we did it that way or this way. Takes a little practice. This is hard because you're doing the tangent of an arc sine.